Alex here. Sorry about the late post. I'm going to try and get this done in short order. I spent a lot of time on the simulation and as such won't have too much time to work on the video here. So please bear with me as I kind of explain what I'm doing. Um, what I did for my simulation and model and everything was we were playing some poker this last weekend with the family and played a couple different games. In probably about 50 hands I managed to get. We were playing Texas Hold'em, which is a style of poker where you deal 2 cards to every player, and then there are 5 community cards that get flipped up. In about the 50 hands or so that we played that night, I got a pair of aces or a pair of bullets twice during that duration, which I thought was definitely odd and kind of allowed me to sweep both games pretty handedly. So I was curious as to how frequently that might occur. But one of the things I ran into while I was considering how to model this was that every card in a 52 card deck of cards is unique, so that like once you eliminate one by dealing it to someone, you're not going to have that card available anymore. So to kind of work around that, rather than just assigning a value of 1 to 13, is like that's the number of types of cards there are, or what do they call them? Irrelevant. Anyway, so I assigned 1 through 52, and the aces are 1, 14, 27, and 40 respectively. Um, so I was curious as to how frequently something like that might actually occur, and so I started running simulations. This is sort of where I got tied up. So I had 2 cards dealt to each player. I was imagining an 8-player game, which is usually a normal, decent-sized poker game. So you deal 1 to each player, and then go back around the table. So the first card and the 9th card would be player one's cards. So I was trying to accurately represent that. Probably didn't have to quite go that in depth, but I just didn't didn't think about that as I was doing this. So, but I thought it'd be a little more accurate to model it that way. So that's what I did. I wound up running my initial 30 simulations and literally had no one that you can kind of see over here, no one that even had uh, more than one ace that entire duration, and in fact, only in one of the initial opening hands did we get more than 2 of them on the table. A lot of them were zeros actually, so we weren't seeing a whole lot of aces there, so I decided to drag everything out to 100 trial simulations, and in that entire time, there was actually only one instance of a player getting 2 aces in the opening hand, which was player 4, the green player here. So I decided that that wasn't really going to be all that after doing all this work. Went through and kind of found all the aces, color coded them to which player had drawn them, and then I was like, yeah, this is really not going to be all that interesting to look at. Just one person getting this. I mean, obviously, if I were able to do more iterations of this, it would be a little bit more interesting to look at. But I kind of ran out of time here, and the other factor that I ran into was that because you don't want duplicates of the cards, since each card is unique, I had to go back through and kind of weed out duplicates in each hand that was dealt. So that kind of threw me back a little bit. I actually got about halfway through and I was doing it for every number, and then I was like, I really only need to do this for aces. So there are probably still some occasional, right here, 242s in that hand. So there are probably some duplicate numbers, but it didn't really throw off for what I was looking for. So yeah, I decided to look at the total number of aces that were dealt in each hand, just kind of like a histogram distribution there, and then I wanted to look at like a bar chart of how many aces each player was dealt throughout the duration of the game. So total aces dealt in the starting hand. It was really kind of all over the place. As you can see, there's only one hand where actually all 4 came into play in that initial hand. Which I thought was pretty interesting. And we had a few where there were 3, probably, or looks like around a similar number where there were 2, and then plenty of hands where 1 or even no aces were dealt to any player. I had to make this kind of large just so you could see it very well, and I still couldn't get all the numbers to display, but it's only every other one. So each of these bars and or spaces you're seeing is representative of that particular trial, which I thought was a pretty decent display of the distribution. Anyhow, then I hopped on over here to just kind of look at the number of aces that were dealt to each player, which I thought would be a lot more uniform, considering that it's a game of chance initially, and then you kind of do a lot of bluffing and other kind of tactics to try and beat your opponents out for chips. But I was really kind of surprised to see player 2 and player 7 up here with like 17 and 18 aces each, and player 8 only got 6 the entire time. So it's a pretty wide margin of aces dealt to each player, and I imagine, considering what we've learned in this unit, that would continue to sort of even itself out and become more uniform as I did more trials. But just given the nature of randomness, this is kind of what we wound up with, and so I found that very intriguing. I apologize that I didn't get a chance to really look at the numbers any more in depth than that. I just spent so much time on doing the simulation and trying to get examples of what I was looking for that I didn't have a lot of time to tackle some of the other descriptive statistics. So yeah, I apologize for that, and I hope you guys at least found what I was looking at interesting, and thanks for bearing with me. Hope you all have a great rest of the week, and I look forward to discussing with you. Bye-bye.